Hello again, Mercedes here, and welcome back to the Clark Planetarium classroom. Today I'll be taking you guys back to the meteorite exhibit to take a look at some more out-of-this-world rocks. Before we head over to the exhibits, let's take a look at our planet Earth. Alright, so here is Earth, and it is the largest of the rocky planets. The rocky planets are the small planets in our solar system, and Earth is the biggest of those four. Now, the moon is only about 1/4 of the diameter of the Earth. The diameter is a straight line across a circle. So if we use the equator on the Earth here, this nice straight line, we can fit 4 moons across it. That's what it means by 1/4 in diameter. How did our planet get such a large moon? Where did it come from? Let's find out. The reigning lunar origin theory is that our moon formed about 4.5 billion years ago in the infancy of our solar system. Rewinding to that time period, our planet Earth was hit by a lot of different objects during that time. A lot of debris, asteroids, all sorts of things that were just from the formation of our solar system. Scientists think that one of those was actually a full-on other planet. That planet was nicknamed Theia. Theia was smaller than the Earth, is about the size of Mars, and it hit into the Earth, casting the Earth's crust and other objects out into space, and those eventually formed what we now have as our beautiful natural satellite, the moon. Other theories talk about our moon forming at the same time as the Earth, that they just formed side by side and it just happened that way. And there's another that theorizes that the moon formed elsewhere and was later caught by Earth's gravitational pull. While these are good theories, the impact theory fits better with our knowledge about the moon's composition. Part of that knowledge came from the rocks collected on the moon by the Apollo astronauts. In 1971, a Saturn V rocket launched into outer space carrying with it 3 astronauts. 2 of those astronauts landed on the moon and started collecting rock samples. That was the Apollo 15 mission, and with them, they brought back our very own moon rock. The lunar mare are large, dark basaltic plains of the moon, and basalt is a common rock that forms from rapidly cooling lava. Basalt is present on both Earth and the moon. Chemical analysis revealed that this rock formed from volcanic lava. It is a mare basalt. That means our rock is from a mare, or the dark region on the moon. Let's talk more about Apollo 15. Our rock sample here is actually a small sample of a larger sample size that they brought back. Apollo 15 was the 4th mission to land on the moon, but it was full of firsts. It was the first to use the Lunar Roving Vehicle, or Lunar Rover. This allowed the astronauts to cover a large area for sample collections than previously possible. During the mission, one astronaut performed the first spacewalk in deep space, collecting film from the exterior of the spacecraft. It was also the first mission to launch a satellite while in orbit. The crew of Apollo 15 received extensive training on Earth prior to their mission to allow better descriptions of what astronauts were seeing on the moon. This allowed them to understand rock types and other terminology that helped them communicate what they found to Earth-based scientists. The commander, Dave Scott, conducted the famous feather and hammer drop experiment. So this rock is just one of many, many rocks that were brought back from the moon by Apollo astronauts. Now here at the planetarium, we don't have just the one moon rock. We have another rock that came from the moon. Do you guys remember what it is from the Mars meteorite video? Let's go check it out. Here's the lunar meteorite we took a glimpse of a few weeks back. This is a rock that was flung from the moon when it was hit by a meteorite. The small moon rock traveled through space and eventually hit the Earth. This is our lunar meteorite. Remember the question I asked in the meteorite exhibit video? Why do we have meteorites from Mars and the moon, but not other planets? Well, here's your answer. The outer planets are made of gas. So if a space rock impacts one of them, it will just burn up in their atmosphere. Venus has a very thick atmosphere, so rocks blasted off its surface by an impact will slow down significantly due to air resistance. They are unlikely to reach space. Meteorites from Mercury are a possibility. However, Mercury is so close to the sun that any rock blasted off its surface would need to move incredibly fast to reach Earth's orbit. I hope you learned something new about the moon today. If you want to learn more, check out the links in the description. And remember, keep asking questions, keep exploring, and keep looking up.